All right. So first things first, it's the roof plan. This is what you always start with the roof plan. Um, Usually, what you use because the type of wood that we use in North Carolina is Southern Yellow Pine. So what you will need to do first thing is you'll need to check out um, what the spans are. Typically, the best thing to do is to see if you can make it so that way all of the so that way you can make it uh, all the spans span out to out, so that way you don't have any interior loadings. So what we'll do is first we'll check our spans, and by the spans, everything goes based off of horizontal projection. So typically you'll just have to look at these spans. So here we've got 16 foot 4. Um, Same thing here, 16 foot 5. Um, Here, um, technically it's from here to here, but this wall right here is this exterior wall here. So we can use that as roof support. And typically, anytime that you have an exterior wall, because exterior walls always have foundation walls under them, you can use them as roof support. Same thing for here. This is a wall here, an exterior wall, because this is the porch. So you can use this wall here as support. So uh, this span from here to here is 22 foot 1. Um, that's a little long, so we're not going to be able to get that long of lumber. However, from here to here is 15 foot 3. Um, and one thing you always want to have handy is you will always want to have your Southern Pine span tables. So this is from the Southern Pine website. Roof loading is 20 psf live load for North Carolina, unless you're in the mountains or you're somewhere else like Virginia where you have a lot of snow load. Then you'll have like a higher live load. But for usual roof loads, we use 20 psf live load, 10 psf dead load. So 20 live, 30 total. Um, and typically what we want to use is 2x8s at 16 inches on center. 16 inches on center is the common spacing. So we'll use either 2x8s. For really short spans, we'll use 2x6s. And we always use number 2 grade because that's the most common grade. So as you can see, 2x6s at 16 inches on center can span 13 foot 5. 2x8s can do 17 foot 1. 2x10s can do 20 foot 3. So what we'll do is typically go with 2x8s unless it's a really small span. Then we'll do 2x6s, or if typically if it's anywhere between 17 feet and 18 or 19 feet, we'll go with 2x10s. Otherwise, we'll want to break up those rafters because it's really hard to get lumber 20 plus feet long. So we want to break that up with the roof support. So right here we can see that 2x10s are 2x8s, excuse me, can span 17 foot 1. So what we will do is use this wall here as roof support because that max span now is 13 foot 3, and we use this wall as a roof support, and now that span is 15 foot 3. So now that we've got that out of the way, we can also from here to here. This can span by itself, be 2x8s at 16, as well as this span. It's 11 feet, so we can use 2x8s as well. So let's see. The issue is, if you've noticed, we have this wall here. It continues to here, but we have this 12-foot 2 span that is 22-foot 3. So what we would need to do there is add a support somewhere in this area. That's where we come down because there's not really a second floor. This is like an attic space. So what we'll need to do is come over here and see if there's a wall here. If there was a wall that lined up here somewhere within this vicinity, we would use it as roof support. But because there's not, I think the easiest thing to do here would be to add a roof support beam to support that. And that way all the load can just continue straight in that same line, and you don't have to worry about using a wall somewhere in here and lessening the amount of space they have to walk in here. Um, Also, something to be aware of: anytime you have a valley or a hip, this is a valley because these rafters come down here and they come down here and they're loading onto it in that direction. Um, the rafters always have the most load at the bottom. So, because of that, hips, like right here, because they're going from top to bottom and top to bottom, so the lesser amount of load is on this member here. Hips always have less load than valleys do because it's going from top to bottom and top to bottom. So we'll need to size that. Sometimes what you can do is you can overframe the rafters. Um, However, that only applies at valley locations. Hips are always going to need to be framed. However, valleys can sometimes be overframed. Typically, what you want to look for when it comes to valleys to determine whether or not they can be overframed or they actually have to be true valleys, you come down to wherever it is. In this case, it'll be in the second floor. And you see how this line is here? This indicates that we've got flat ceiling right here. However, the roof is sloping down. It's sloping down here to a shorter wall. Same thing here. You've got flat ceiling here, but it's sloping down. Typically, the easiest way to look at that would be to look at the architectural plans. Let's see. Yes, here. So, as you can see, we've got 4'8" knee walls here. And this is the first floor wall down. So basically, you got your 8-foot ceiling, and it's sloping down to a 4'8" plus or minus wall height right here. And it's pretty much sloping down in this same section here. And this line here is where that valley will be. So now we can come back over here to our plans, and excuse me. Now you can see that that needs to be a true valley. So we will size this valley accordingly. So now what we will need to do is come in and size our rafters. So like I mentioned before, that's 11 feet. It's 11 feet. So like I mentioned before, we will need to come in here and add our roof support. Luckily, we have a template that has most of the things that you will need. It has a lot of notes, hatches, section cuts, double rafters, plates, call outs for hold downs, notes for breaking on the wall. We even have some roof truss notes. So this area here will be a roof support like we talked about before. So we'll just come down here, match properties to that, and then there you go. So, and we'll come here, copy that note, roof support, roof support. Because this will be a beam that we have to size later on the first floor plan, we would just add roof support beam below. All right, so now we can get down to sizing our rafters. Like I mentioned before, 2x8s at 16 inches on center, which is the most common rafter size, and it's what builders want to go with most of the time. They span 17'1" per code. So what we do is we come down here, we select our joist, copy it. You can use Control C. That's one of the things I like about it. You can use Control C, or you can do the copy command. And then we can rotate the rotate command, which would be RO. Um, a trick, because sometimes if you have when you try to rotate it, it won't be straight. What I do is I click F8, and then that makes it so you can only do a 90-degree angles. So that way you know it's straight. And what you do is you'll come here, you'll extend this to the ridge because that's where it's going, and you'll extend this out. Um, and then we will change this to 2 by 8. How you do that is you just go in here and you'll just double click it. Either that, or you can click it. If you have your quick properties up, you can come in here and just change this text, or you can right click, select it, right click, and go to properties. And then I already have mine up over here, but you can go over here to text, and the text is right here as well, and you can edit it there as well. But I find it that the easiest thing to do is just double click in here and change it. So there we go, and then we just kind of move it here because it's the same everywhere. And because this is used as roof support, what we do is we can come down here for this note, because they don't necessarily have to run those rafters continuous and support it there. They can break those rafters on that support wall. So what they would do is come down here to this note where it says support / break rafters on knee walls below. We can copy that and over here, then just move that arrow to there. And there you go. And then we'll come over here and we'll do the same thing. Now sometimes whenever you move this, the text will stay the same. Like here, right? You see how the text continues to move and is not centered. Anytime that happens, all you have to do is hover over this blue dot right there, and then all these options will come up, and then you can just click here and say reset text position, and then it will go back to the middle. And then we come back here, we copy that, and then this makes it kind of difficult because just trying to find a place to place it. There you go. Let's move that over a little bit so that way we have some room. All right. All right. And then we need to copy this as well and let them know that this wall here will be used as roof support. All right. So now we copy that and do the same thing here. Copy it. There we go. And we can do the same thing over here. Rotate it. RO is the command for rotating. F8, so that way we can make it so it's straight. And then we just stop it at the center. So this case is a little weird because they have these tails here. What this typically they will look like this, the overhangs. They will just come out straight. However, this section has because it is sitting on a knee wall, and we can tell that by looking at the section from the architectural drawings. As you can see, they have these little tails right here. This is an architectural thing. None of that is structural. What they will do is in the field, they'll just, nail that on for looks. So basically, we can just stop our rafters right here. As you can see, they're sitting on that wall right there. All right. All right. So right here, this section, this walk-up section, we'll come back over to the first floor plan. This bonus room, because these sections are sloped, what we'll need to do, they'll have to insulate these rafters, and per code, you have to have at least 10 inches of insulation. So that's why in bonus rooms, you'll never want to go less than 2x8s. Sometimes even um, builders will want to do 2x10 so that way they don't actually have to fur up the rafters. And by furring, what I mean is what they do is they add sections onto the rafters to make them deeper, because they're not needed structurally. However, you need them for insulation. So what they'll do is they'll add additional member to the rafter so that way they can get the 10 inches of insulation that they need. Because a 2x8 is only 7¼ inches deep, they'll just typically either add a couple of furring strips or maybe even add like a 2x4 to the bottom of it so that way they can get their proper insulation. So because of that, what we'll need to do is come in here. You have 2x8s, and we'll just double click and we'll enter parentheses fur to accommodate insulation. There you go. And we can just copy that, come over here, double click it, enter. There you go. Cool. Well, that part's done. So now there's two other things that we can do. So you see this little area here. We can size that with 2x8s as well. However, it's a very short area. It is from the ridge to the wall, 5'6". And also, this is an area that is not a part of the second floor. So because of that, we can use 2x6 rafters. And as I mentioned before, 2x6s at 16 inches on center can span 13'5". So we can come over here, copy that. I find copying to be the easiest thing rather than going down to the template and selecting it every time. So we can delete this section and then change that to 2x6s. And then sometimes things will go awry. So like I mentioned before, you can just hover over that middle selection and select it and reset your text position. All right, there we go. And as I mentioned before, these little tails here, those are just purely architectural. So what we can do is come over here and say, just what do we want to say here? Overhangs to be field framed. And then we can mirror that. The mirror command is MI, or you can come up here and select mirror. Select that, and then copy it. Then that, right click, add a leader. Well, actually, I can remove that because this will just be a regular section. The reason why these tails are here is because, like I mentioned before, these rafters will be sitting on this knee wall. and these won't. These will just be sitting directly on the wall. All right. So now that the sizing our rafters is done, what we need to do now, there's 3 more steps. I think, yeah, 3 more steps. So we'll need to size our valleys and hips, and we'll need to size our ridge and collar ties, and then we'll also need to size the support for these dormers. What the dormers are, we come back over to our architectural plans. They are these little sections here. Um, so yeah, that's what they are. You see those a lot in houses, and because looking at the plans, you can see the second floor plans are not finished. This is just in a walkable area. So because of that, what I'm going to do is I'm just going to overframe these, and they won't actually be inside. Um, they won't actually be walkable into these areas. Sometimes you can make them walkable. In fact, a lot of times you will be. But because we're using this wall as roof support anyway, um, we won't worry about it. Let's see, unless another way to verify is they have this section cut here on 501. So here, yeah. So as you can see, here's where the dormers are, and they don't show these areas as an area that you can walk on. So because of that, I think we're good to go. Also, the first floor has a tray ceiling in which you can't even walk on it anyway. So typically, well, we'll talk about that once we get to the second floor. All right. So because here's how you size a ridge. So a ridge is typically one size bigger than your rafters, unless your roof pitch is 912 or above. As you can see, this roof pitch is 812, so we're using 2x8 rafters, so we can use a 2x10. However, here is a 1212 pitch. Because of that, what we'll need to do we're using 2x8 rafters here as well, but we will need to use a 2x12 ridge. And we're using 2x6s over here, so we will need to use a 2x10 ridge. Let's see. And luckily, we already have the note for it. So 2x10 ridge with 2x4 collar ties at 32 inches on center is our common note. Because what collar ties do is they keep the roof together, and they prevent the roof from thrusting out and bowing. And if that were to happen, you have risk of your roof pushing out and sagging in your roof without collar ties. So what we'll do is we'll copy this note here, bring it here, 2x10. There you go. Yep. We got 2x8s, 2x8s, 2x10s. Same here. We got 2x8s, 2x8s. So we use 2x10 ridge. All right. However, like I mentioned before, because this over here is the 1212 pitch, what we do, rotate that. So 2x8s, 2x8s, we'll need a 2x12. Also, we can't use this same note with 2x4 collar ties at 32 because this section has ceiling joists. So what we do is we will use this note instead, 2x10 ridge with 2x6 ceiling joists / collar ties, because the ceiling joists are also acting as the collar ties, and the ceiling joists have to be at every rafter. what we will do is we'll do this note with 2x6 ceiling joist / collar ties at 16 inches on center. So we'll just copy that part of it because the rest of this is actually the same. So there you go. All right. So we've done that part. We've done our collar ties and our ridges. So now what we have to do is the dormer. Because this is a very small section, what we'll do, come here, here, all right. There we go. And then we select those two, we copy it, select a base point, select it, there you go. We've done that. Now we do our ridge. Because this is also an 8/12 pitch, we can go one size above. So 2x6 rafters, 2x8 ridge with 2x4 ceiling joist / collar ties at 16 inches on center. And the reason why I do that, have them similar to this, is because if we look at the section that I showed before, for the roof on the front elevation, as you can see, these collar ties, well, these ceiling joists, as you can see, they bear on top at the rafters. They show them with the ceiling joist there. So what we'll do is we'll just follow that. We'll just follow that and pretty much have them use the 2x8 ridge because it's one size bigger, and then just use 2x4s for the ceiling joist because it's literally less than 4 feet. There you go. Select it. Copy that. There you go. Okay. Now, when the last thing we have to do with these dormers, we have two things to do. One, because these dormers will be overframed, and by what I mean by that is you don't have access to them. They'll build these on top of the rafters once they finish building this main section of ridge. So because of that, this note here we have specifying a plate. We'll just put this plate here, and what I do to figure out what that angle is, I just come down, use my measure tool, and then it'll tell me that that angle is 56.3. So select that, and then we go 56.3 is the rotation angle, and then there you go. And then we can just, rather than figuring out what the other angle is, we can just mirror it over this line because it's in the middle. And then we can copy that. Anytime there's overframing, you'll have to add the plate note right there. Just because in order for them to frame it on top of the rafters, they have to put down a flat 2x plate to nail these rafters onto. All right, and now we have to support these walls with a rafter. So what we'll do is you come here, you bring this all the way up, you offset that 2 inches. Because the walls are drawn as 4-inch walls, to put them in the middle, you just go over 2 inches so that way it's shown like it's in the middle. Well, let's not do that actually. Show it as a double rafter. Right. Rotate. Move it. to here. Oh, select that, fit center here. All right, and I kind of did some other things. Basically, what we'll do is we'll support because these dormers they're sitting on walls. These rafters they're sitting on walls, and these walls have to be supported. And there's two ways to support them. One, you can either bring them all the way down and then support them in the ceiling, and you know with beams and all that kind of stuff. But I find that to be I try to keep everything in the level where it's at if I can, if I can help it. But so for here, because these areas are so small and they're not really carrying a lot, I think typically what we do is support them with double rafters. And what we'll need to do there is use Forte to size those double rafters and make sure that they work. So what you do, come into Forte, you start a new job. This job number is, let's see, 2101 010 448. Okay, we'll name this level the roof. And we'll add a roof beam. Our roof pitch is 8. All this stays the same. Okay, and then, let's see, we come over here, we measure. So from here to here is 6 feet, and then from here to here is 13 foot 3. All right, then we come over here to Forte, 6 feet, 13 foot 3. So change this to custom dimensions. This, we'll just say it's 3.5. Well, let's just change this to 3 because this will be a beam. That's from the left side. And then this one is also from the left side. This will be 3.5 because this is where the wall is. So below, it's a beam that's being supported. Southern pine. Southern pine is the wall. Okay, and then the ridge is just a 2x10, so that's 1.5, and then that'll be in the center, and then face mount hanger, because I mean they don't actually use face mount hangers at the ridge; they just nail it off, but they don't really have the option for it to nail off. So there you go, and this is what it would look like, that rafter sitting here and sitting here. Okay, and now we add our loads. So you've got, all right, let's just start at 0. So from 0 to, let's call it 1'6", you have just the roof, nothing else. And then from 1'6" to 8, well, that's not 8'3", to 9'10", let's call it, you have the weight of this roof, so half of this, which is 3'8", so half of that of roof, and then half of that of ceiling as well. And then from there to the ridge, you just have roof again. So we'll just recreate that in Forte. Add our loads. So PSF from 0 to 1'6". Our trip area is 1. So 10 pounds dead load, 20 pounds roof load. All right, we can just copy that, and then from 1'6" to, what's this again? To 9'10", we have half of 3'8". Let's see, we come out to our calculator. So we have 3.66 divided by 2, which is 1 foot 10. So 1 foot 10 of. So we have our 10 pounds of dead load from our roof, and we also have 10 pounds of dead load from our ceiling. So that's 20 pounds dead load, and then our live load, because it's ceiling load, and the difference between the two ceiling loads, we'll go more in depth into this once we get into the ceiling. But we have 10 pounds live load whenever there's no storage there, and whenever there is storage, use 20 pounds live load. But because this is just a short, small ceiling on a dormer that's not even accessible, it'll be 10 pounds live load. All right, and then 20 pounds for the roof. All right, and then that's it for that. And then we just copy this again, and then from 9 foot 10 until the end, we just have 2030 loading again. Because at that point, nothing's here anymore. It's just the roof. So you just close this. This is the architectural file, by the way. All right. So now that we've got our loads there, come to our product selection. First thing we want to do is see commodity lumber, Southern 2x, Southern Pine number 2, and then 2x8s. How many 2x8s will it take? Because we're using 2x8s in the rafters, so we might as well use them. And I just select all of them just to see what'll work. Right. So technically, a single 2x8 will carry that load. But whenever something is carrying something, where it be a floor joist or, a beam or any of that kind of stuff, you never want to go with one ply. You always want to go at least 2 plies. So we'll do a double rafter. And then this gives us what our load at the beam is going to be, which is basically nothing. Our load on the wall, which is also basically nothing. And then our load at the ridge, which is basically nothing. So there we go. So we know a double rafter works. So we can come here, copy that, DR, that's what double rafter stands for. Come here, let's move that out of the way. The rotation, 90 degrees. Just come here, and there you go. Double rafters, they work. Here you go, here you go. All right. So the thing about having a double rafter is you always want to oppose that double rafter with another double rafter. The reason for that is because you don't want the load that's going there to push out the ridge. You don't want it to bow that way. So in order to prevent bowing, we just put another double rafter on the other side. However, you don't need to make it go all the way to the end because it's strictly only there for support on this side. So we can just go copy that. I think something happened there. I don't know what happened. Yeah. All right, let's do that again. Copy here, 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 here. All right, and then we can trim that, because this is all roof support. You can trim that. There we go. And there we go. All right. So now what we have to do is, because we're using this here, this as support, we'll need to put our stud columns in and what our loading is so we can track all that loading down. When you're copying stud columns, always make sure to get the full, because this is a square with a hatch in it. Make sure you always get the square too, so that way you can grab it. All right, come over here. We'll just say 2 stud columns. It's the same thing for everywhere else. You can just mirror that. Just copy that. Oh, I already copied it. Sorry. All right. So now, where do you may ask, where do we get our loads from? That's where we come back to Forte. And so here we've got what our, oh, I don't want to do that. We've got our dead load, our live load, our roof live load, and what the total load is. So this total load is actually just all these added together. But because the floor live load, which in this case is just ceiling, and the roof live load, they don't act at the same time. Sometimes they do, but most of the time they don't. So because of that, we actually have a load combination that we can use, which is this one. So you see how this says 869, but this says 999? Actually, what this is 0.75, so 75% of this load plus 75% of this load. Typically what you'll do is you want to see which one controls. So sometimes just the floor load will control, sometimes just the roof, and sometimes the combination of both. You'll just kind of want to use both of them just to see. And actually, there is a spreadsheet that I created that allows you to not have to do that. It's called the load cases spreadsheet. And opening it right now. So basically, all you have to do is you have your dead load, your live load, your roof load. Sometimes you even have wind load. So that's usually only in high wind areas. So you don't really have to worry about it. So what you do is you'll enter your dead load, which is 480, your live load, which is 131, and your roof load is 388. So your largest live load and your largest total load. So the combination that won out is, they're down here, as you can see, is 389. So that's the 0.75 of roof and live, and then your total, which is 869. So that should be the same as, there you go. See, 869, 869. That's where that comes from. So we just come back here, change that to 389, 869. And there we go. Copy that. I know this is one extra step, but trust me, it's going to save you a lot of time in the future. Because then you won't, whenever you have like point loads and things tracking down, you don't have to re-engineer it to figure out what that load is. It's already right there. So you can go into it like that. So now 2 more things. Sizing our hips and valleys, and then going in and sizing our putting in what our loads for our roof support is. So let's do the loads first because that's the quickest way, I think. So here we just copy that, and we'll copy that. So here, how we figure out what the load here is, you just do tributary area. So for this wall, we know that this is acting as support, this is acting as support, and this is acting as support. So what the tributary area is half of this 6 feet plus half of this 28'6", because this is the next support. But the easiest thing to do is just go from this area all the way here and then just divide it by 2. So we've got 34'6" divided by 2. So 34.5 divided by 2, 17.25 feet. So we know that now there's roof load going on that. So we can just do 17.25 times 20, which is our roof load, and 17.25 times 30. So there we go. So our loads are 345 roof live and 575.5 total. But we don't split hairs here, so we'll just call that 518. So 345 and 518. Roof. 345, 518, yeah, left. All right, and then we can just copy that. Oh, looks like I already copied that, so let's delete that. Come here. And this is the same throughout this section because all this stays the same. So this is from this support to this support, which is 35'6". So this was 34'6", and that was 35'6". So really, you just add an extra 6 inches to what this is, so it would be 17.75. But let's go through the exercise, shall we? So 35.5 divided by 2. Oh, 17.75, like I mentioned. So you do the 17.75 times 20, 17.75 times 30. And we have 355 and 532.5, but we'll round up to 533. So 355 and 533. All right. So those are our loads on these roof supports. So now let's come in and size our hips and valleys. So because there will always be a support underneath the hip and valley, we will go ahead and add those. The reason, sometimes you will show how many stud columns there are and other times you won't. The reason for that is because basically the ones that go above the wall, those are the ones you'll show. But like for here, because this is where the rafter starts, and up here it's actually sitting on a knee wall. So because it's sitting on a knee wall, you need to indicate how many studs are going to be in that knee wall. But here, these studs will actually be inside the first floor wall. So we can label those on the first floor plan once we get there. So now what we'll do, let's size the hip first because that's smaller. So you can size hips in Forte. I typically don't like sizing hips in Forte just because it takes longer. So what we'll do is we will come in here and we will open up beam check. All right. So we come down here to hips and valleys. Our duration load, because it's in the roof, we can go 1.25. And our live load deflection and our total load deflection, because it's in the roof, can be 240 and 180. All right. So the thing about beam check is you don't need to enter what the loads are for that because it'll automatically calculate that, and the span length, it'll automatically calculate that too, unless you have like you have something weird going on where The hip doesn't go all the way to the ridge. It's only going to a certain amount of time, but it's still collecting the load from everywhere. This isn't that. This isn't the case for this one. So what we'll do is we'll size the hip. You go from here to, well, that's not actually what it is. Because it's acting stupid. We will come from here to there, and then we will extend it out so we can get to of it. So from the ridge all the way to the wall. Oh, well, yeah, I guess we could just do that too. So here we have 11 feet, and then here we have, just call it 16 foot 5. So what we do, we come here, we go, so from left to right here was 11 feet, and from here was 16 foot 5. As you can see, that resembles it a lot, right? So there's the hip, right here, right here. So you got these check marks. What do they mean? So basically, if you have a hip, the load is only happening on these two. You only check these two. But if you have valleys, you'll check both of these. However, sometimes it's acting as a hip on one side and a valley on the other side, depending on the roof style. Those are more complicated roofs, but in this situation, it's just a hip. So you only need to check in the two, and you need to put what your roof loading is, which is 20, 30. All right, and then you click OK, and we have the auto span auto calc checked, so it'll automatically check that, and then we go. There you go. And then let's see what it spits out. So right now it's giving us a 314 2x14s. Those don't exist. Typically for a hip, you'll always want it to be 1 ply. Sometimes you can do 2 ply, but for the most part, you want it to be 1 ply, unless it gets ridiculous. Like if you have like a 24-inch LVL, or you have to have an LVL versus like two 2x12s. Two 2x12s is way cheaper than 1 9 1/4. So let's go over here. Let's see what an LVL would be. 111 7/8. It's at 92%, but it's a hip, so we'll allow it. Unless, let's see if there's a good location down below to add a support. So you got this wall here. Let's see where it actually lines up. What do you know? It lines up right there. So let's use that as a support, shall we? There we go. And then, I'm guessing that this wall will make great support for the valley. Yep. And there you go. So, I know we just sized it for the full span, but what is this? From the span, it's 10 inches off from the full 19-foot span, so we can just keep the loads the same. It's actually being conservative, so that's fine. And then do that. Now, what is this angle? Just like I mentioned before, we just come over here, use our measure tool, and it'll tell you 56.3. We will use 111 7/8 inch LVL hip. Now, technically, you can use one of these interior walls below to support it. However, I prefer to use as little wall support below as possible because then you have to worry about where to support it in the foundation or if you have to support it on a beam, and that just causes more trouble in the future. So we've sized that, and then we come over here to what our loads are. I'm just copying the loads from before, so that way I can change them. But let's see. So this load here, the thing about a hip, hips and valleys, they will give you the same reactions, R1 and R2. However, for a hip, all the bigger load is at the top. So this 1859 would be right here, and this 956 would be here. However, if it was a valley, it would be the opposite. So if it was a valley, this 956 would be here, and your 1859 would be here. So this is 1204, 1859. And this is 602, 956. All right. So this is the valley. All right. So 16'6", well 16'5", and then 11 feet. So it's the same as it should be because they should be in the middle. So now since this is a valley, we'll check these. So this would be the load for that full span, but remember, we don't actually have that full span. It is actually here to here. So it's actually 16'4". And because of that, we can still use those loads, but it's not entirely accurate. So usually when I have something like this, I'll come to Forte. Add it here. Have a valley. Hit valley. Come to roof geometry. Valley. Base mount hanger. We have roof. 20, 10. We do have an intermediate support. All right, and then 16'5", 11. This is 12. This should spit out 8. Well, close enough. All right. All right. So here's what we have now. Now we need to, because we have a support, we have to tell them where the center of that support is. So from here to here, 13'4". All right, that's what our load looks like. Change all this to Southern Pine because we don't actually use spruce. Everything stays the same. Yep. Now this will probably change. The reason being that, well, never mind. No, it won't, because all this is the same. So sometimes what you have to do if you have a configuration in the second floor where you have ceiling joists that turn directions, you will have to add a beam here, and then that beam will secure to the valley. So that's going to add a point load onto your valley, which makes your valley bigger. However, we don't have that situation because we can just extend these these ceiling joists out to here. So won't be a problem. All right. So let's figure out what it is. Shall we see if our double 11 and 7/8 still works? Show only ones that pass. Oh, I bet you it's going to say that the double 11 and 7/8 doesn't pass because of excessive uplift. Yep, told you. That's what it's saying right here. It's saying that because this is so close, this is going to cause excess uplift right there. However, it's actually not how that'll work. This is all acting like it's together, but really what they'll do is in the field, they'll frame this valley here, and then they'll come back later and just put this underneath it. That's kind of how that works. So the loading on that would be 1567 and 2884, and then 917 and 1607. So this one was 1607. This one was 1567, 2844. All right. Because these are bearing on the wall below and they'll be above the wall, we'll have to tell them how many stud columns they will need. So we'll make that 3 stud columns. Make this 2 stud columns. The reason why I did 2 here is because there's 1 ply, and over here will be 2 ply valley. All right, and there you go. I know that was a lot, but now we have a completed roof plan. Next, second floor plan.